Hey, welcome to The Explainer. Today, we're talking about something that sounds like it's straight out of a sci-fi movie, but is getting closer and closer to reality. Space-based solar power.
I mean, just think about that for a second. What if you could get clean energy from a source that never shuts off, isn't affected by the weather, and works day and night? That's the big, bold idea we're digging into.
So what is this exactly? Well, at its heart, space-based solar power, or SBSP for short, is the concept of building gigantic solar farms, but in space. These satellites would just soak up the sun's rays, convert them into another form of energy, and then beam it right down to us here on Earth. And if you're thinking this sounds like some wild, futuristic idea, you might be surprised to find out that this dream is actually more than a century old.
Believe it or not, this idea goes way back to the early 1900s. It was formally designed and patented back in the 60s, and NASA was even running studies on it in the 70s. But for decades, it was just too expensive. The technology just wasn't ready. But now, with the urgency of climate change and huge advances in things like reusable rockets, this old idea is suddenly getting a very serious second look. All right, so how on Earth, or I guess off Earth, does this actually work? It sounds incredibly complicated, but the basic idea can be broken down into 3 pretty simple steps. Okay, so here's the game plan. Step 1, you put these huge solar panel arrays way up in geostationary orbit, about 36,000 kilometers up, where they're in constant sunlight. Step 2, that sunlight gets converted into microwaves and beamed down very precisely to a target on Earth. And step 3, a special receiving station on the ground, called a rectenna, catches that microwave beam and turns it right back into electricity that we can use for the grid. Simple as that. Sun to socket by wave space.
The easiest way to think about this is like the wireless charger for your phone. You put your phone on the pad, and it just charges, right? No cables? Well, this is the exact same principle. We're just swapping out your phone for the entire planet. It's basically a gigantic wireless charger in space.
So we've got the how. But what about the why? Why are governments and private companies suddenly pouring so much time and money into this? What is it that makes SBSP a potential game changer?
This right here. This is the magic word, 24/7. The biggest challenge for renewable energy on Earth is that it's intermittent, right? The sun goes down, the wind stops blowing. But in space, the sun is always shining. There are no clouds, no nighttime. Space-based solar completely solves that problem by giving us a constant, reliable, nonstop flow of clean energy.
And when you put it side by side with the solar panels we have down here, the difference is just stark. Ground-based solar is on again, off again. It depends on the weather. Space-based solar is continuous and totally reliable. And get this, because there's no atmosphere to filter the sunlight, a solar panel in space can harvest up to 8 times more energy than the exact same panel down on the ground. That's a massive leap. So you add it all up, and what do you get? You get a constant stream of clean energy. You reduce greenhouse gases, and you need a much smaller footprint on the ground. And you could even, get this, beam power directly to a disaster zone or a remote village that's completely off the grid.
Okay, I know this all sounds almost too good to be true. And look, we have to be real here. If this was easy, we would have done it ages ago. There are some major challenges to get past before this becomes our everyday reality.
And the hurdles? Yeah, they're pretty huge. First off, the cost. We're talking astronomical, literally, to launch and build this stuff. The engineering required to beam power safely over thousands of kilometers is, not simple. Then there's international politics and regulations, and of course, a big one, public safety concerns. And that safety question is probably the one you're thinking about. Are we talking about some giant death ray from space? Well, no. The system is designed so that the beam itself would be very low intensity. We're talking about the same energy levels you'd feel from the sun on a bright afternoon. And it would be aimed with incredible precision at a secured receiving station far away from any towns or cities.
So for the longest time, all these challenges kept space solar power stuck in the what-if phase. It was a cool idea on a drawing board, but something has shifted. A big something. We're finally moving from theory to practice. And this is the moment it all started to feel real. In 2023, a team from Caltech launched a prototype satellite. For 50 years, this was all just talk and theory. They basically said, okay, enough talk, let's actually try this, and set out to prove once and for all that beaming usable power from space could actually be done. And they did it.
So let's get into what they actually accomplished, because it's pretty amazing. Their mission had three main experiments. Dulce proved that the flexible, foldable structures needed for these giant satellites would actually work. Alba tested a whole bunch of different solar cells to see which ones performed best. And then Maple, this is the big one. It achieved the first ever wireless power transmission in space and beamed a detectable amount of energy all the way back to a receiver here on Earth. That was the proof of concept everyone was waiting for. And you know what happens when someone proves something is possible, right? Everyone else jumps in. Caltech is not alone. It's like a brand new space race has just kicked off, but this time it's for clean energy. Japan, the UK, China, the US, they all have major projects in the works and they are moving fast. So with all this happening so fast, where does this leave us? What's the future look like? We're talking about something that's moving out of the science lab and into the real world as a real market. Well, for one thing, the money is starting to follow. The market for this technology is already valued at over $3 billion, and that's before a single commercial satellite is even up there. Projections show it growing steadily for the next decade. That tells you there's serious economic belief behind this idea. And here's a really important thing to remember. This isn't about replacing wind or solar on the ground. It's about complementing them. It's the missing piece of the puzzle, that reliable, constant baseload power that makes the entire clean energy grid stronger and more secure. It could be the thing that finally helps us hit our net zero goals, all while pushing innovation in everything from robotics to material science. Which kind of brings us full circle, doesn't it? As we desperately search for clean, reliable power, maybe the answer isn't buried in the ground beneath our feet. Maybe the ultimate solution has been floating right above our heads this entire time. Thanks for joining The Explainer.